Hello, academics just around the globe. Welcome to Caltex Academy. In case you're new, my name is Julius, and thank you for coming around. Today on our board, we're going to look at reduction identities, or sometimes we call it reduction formulae. Now we have here our Cartesian plane, and from here we start measurement from 0 degrees, and our measurement takes in this direction, that is anti-clockwise, as positive, and the clockwise is considered as negative. So when we move to this anti-clockwise, we have here 90 degrees, and then at this side we have 180 degrees, and at this point we have 270 degrees. So back to complete revolution, we have here 360 degrees. So in these identities, we're going to consider these 4 different quadrants. So the first quadrant here, we have 2 options. For an angle less than 90, we can have it as 90 degrees minus that angle, say theta. Or after moving complete revolution, we can move again and add some angle, maybe say theta. Therefore, this quadrant, we also have 360 degrees plus theta. So these are the 2 options for first quadrant. And for the second quadrant, we can also do the same. That is 90 degrees, but this time we'll add theta. Now you can see from here to here is 90, and from 90 up to certain angle, anywhere around the second quadrant, we'll have to add a small angle to make 90 plus theta, or we'll subtract the angle here away from 180. It will also give us any angle between 90 and 180. So here the next option is 180 degrees minus the angle theta. So these are the 2 options we have for the first quadrant and the second quadrant. So in the third quadrant, we have here 180, which is this straight line here, because when you move from here, it's 180. Now plus another angle, theta, in the third quadrant. So we can say plus theta here. Then when we move to the last one here, we also have this option, 360. We can subtract away any angle, theta. So up here, we'll have theta theta. Down here, we'll have negative theta. So we have to mark this while dealing with this quadrant. Now, we're going to look at these quadrants one by one. Starting here, this is our first quadrant. And here, all sine, cosine, and tangent are positive. And here, only sine, that is positive. And here, tan is positive. Lastly, in the fourth quadrant, we have cos, that is positive. So for that case, we can name this as first quadrant. Then we have here second quadrant. And we have here third quadrant. And finally, the fourth quadrant here. Now, having analyzed this, we can now move on. Let's tackle them one by one, starting from the first quadrant, then we move on to the second quadrant after the fourth quadrant. So this video is dedicated for us to master these quadrants only. And we have the first 2 are referred to as co-functions. So we have in total 4, because the first 2 here and the next one here only works with sine and cosine. We don't consider tan for it. So there are going to be 4 of these identities that are for 90 and theta. So let's move on and start with our first quadrant. So in our first quadrant, we can consider with the first one here, and we can start with sine. So sine of this angle, that is 90 degrees minus theta, is equals to cosine of this angle, theta, and it is positive. Now I can simply illustrate this. When I have sine of an angle, 90 degrees and we subtract out, like say 10, this will be equivalent to, we said here, cos theta. And we have here cos of this angle here, 10. Now when we subtract 10 away from 90, we get 80. Therefore, sine of an angle 80 degrees is equivalent to cos of that same angle 10. Now, why they are the same is because if you add 10 to 80, we get 90. Now, in that case, these are confusion. If you press from a calculator, you realize that the answers are the same. So we shall prove this as we continue with our lecture in our next video. Feel free and get your calculator, enter sine of 80, and then record down the solution. You also enter cos of 10. You realize that the answers are all the same. Now let's move on to the next one. Here we have dealt with sine. Let's go to cos. So cos of an angle, the same angle that is 90 degrees minus theta, is equivalent to, when you look at here cos, then we will have here sine. So we have sine theta, and since this one is still gotten in the first quadrant, then it is positive, because we said all the trig ratios in our first quadrant are always positive. Now we don't always deal with tangent, so in that case we can move on to the next angle, that is 360, and here we need to consider all the three, that is sine, cosine, and tan. So the next angle is 360 plus theta. Beginning with our sine, we have sine of the angle 360 degrees plus the angle theta. When you look at 180 and 360, then we'll maintain our sine here, not like for the 90, which is a special angle here. So for that case, we'll have this as sine of our angle theta here. And since this one is still in the first quadrant, then the result will be the same as positive also. Now let's move on and look at cos. So for cos of the same angle, that is 360, and we add our theta, this is equivalent of cos of that same angle theta. Now lastly, we move on to tan of that angle 360 plus the angle theta. This gives us tan theta. Now all these are positive because they're in the first quadrant. Now let's move on to the second quadrant and see how it also works. So we can say second quadrant. Now let's take a look at the angle from the second quadrant. There are two, 90 plus theta and 180 minus theta. Beginning with the 90 and we consider sine and cosine, we'll obtain something like this. Sine of the angle 90 degrees plus theta, since it is a cofunction, then we have it as cos theta. And remember, in our second quadrant, sine is positive. And since we're dealing with this original positive here, then the cosine will also carry that positive sign. Now for that case, let's move on to the next one here, and that is cos. So cos of 90 degrees plus theta equals, now this will be sine of the angle theta. But you notice that cosine in the second quadrant is always negative, therefore we'll include a negative sign here because it's only sine that is positive in the second quadrant. Both cosine and tan are negative in our second quadrant, and that is why is this negative multiplying this sine theta. I hope we're together after this point. Now let's move on to the next one here, and that is the second angle because we're dealt with these two, cosine and cosine already. So the next angle in our second quadrant is 180 degrees minus the angle theta. So here we'll have this as cos of angle theta. But remember, cos in the second quadrant is negative. So we will give this negative here. And let's move to sine. We'll have even started with sine here. So sine of the same angle 180 degrees minus theta will be equivalent to sine of the angle that appeared here. If we are given here like maybe 2 theta, then the angle here will be also what? 2 theta. So this one is positive because it is the only positive in the second quadrant. And finally, let's move to tan. So tan of the same angle, that is 180 degrees minus theta, is equivalent to tan of theta. And tan is negative in the second quadrant. So we put negative here for tan. And these are the 5 reduction identities that are got in the second quadrant. Somewhere you can go ahead and even pull out all these two special identities, the first two from the first quadrant and the second quadrant, and we call them as co-functions. So let's group them together, starting from here, and we have sine of 90 degrees minus theta equals cos theta. And the second one is cos of 90 minus theta equals to sine theta. And the third one is here, we have sine of 90 plus theta is cos theta. And lastly, we have this cos of 90 plus theta equals negative sine theta. So you can see from here is only cos 90 plus theta that give us a negative, because the first two are from the first quadrant, which are always positive, and sine is positive in the second quadrant. That is why the third one we also have some positive here. And these are the confunctions that we may use as we continue with our work. And normally it's not frequently used, but if the question is falling under any of these, like maybe you are simplifying something, then you have to remember these confunctions, that when it is sine here, then the result here will be cosine, and if it is cosine, the result will be sine. We just keep on alternating like that, and then please, you need to mark also the signs where it lands on, especially the quadrant where it is picked. And normally we have the two quadrants of the first and the second where we get our co-functions. I hope that together after this time here. If you have not subscribed to the channel, go ahead and do so by subscribing to the channel. And let us push on to the next quadrant, and that is the third quadrant. So for the third quadrant, the angle is 180 degrees plus theta. Now here we'll take the sine and attach to this theta here, and we have sine of theta. But remember, sine is only positive in the first and the second quadrant, and since we're in the third quadrant, then it must be negative. So we have to introduce negative here. Now let's move to cosine, and we have here cos of an angle 180 degrees plus theta equals cos of that angle theta. Now cos is positive in the first quadrant and the fourth quadrant. So for that case, since it is the third quadrant we're dealing with here, then this one must be what? Negative. So let's move on to the last one. The third quadrant has 3 of these co-functions, and we have tan of 180 degrees plus theta equals, so we have also tan of this angle theta, and tan at this quadrant is positive, so therefore it remains here as positive. And as I mentioned earlier on before, you can also try, assuming we have a sine of one of this angle 180 plus, and maybe you say 20 degrees, according to what we have stated here, is equivalent to sine of this theta. And this theta here from our example here is 20. Now when you place there 20, then you reduce down this, because 180 plus 20 are numbers that can be added together. We shall get sine of 200 degrees. So from a calculator, if you enter sine of 200, you should be able to get the same as sine of also 20. The result will be the same. Try it and then tell us also in the comment section whether you've gotten the same results or it is different. But definitely, you must get the same answer. But remember, the answers will give you negatives because we're dealing with the third quadrant. So if you press this from calculator, it must be negative something. Even the same here, sine 20, it also gives you negative something. Now, the same thing if you try with cosine or tan, you have to get the same thing. Now, let's move on to the last one, and that is the fourth quadrant. So in the fourth quadrant, we're dealing with 360 minus theta. Therefore, we can start with sine of the angle 360 degrees minus theta. And any angle can be given there. Somebody can say x, beta, alpha is all accepted. We do it the same way. So therefore, this is equivalent of the sine of that angle theta. And remember, sine is always positive in the first and the second quadrant. And since we're in the fourth quadrant, then the result here must be negative. So let's move on to cos. So cos of the same angle, 360 degrees minus theta, they must give us cos of that angle theta. And since we're in the fourth quadrant, again, the only trig ratio that is positive is the cos. And here, this result remains as cos. And finally, we can move on to tan. So tan of 360 degrees minus our theta, then this will be equivalent to tan of theta. So from here, tan is always positive in the first quadrant and the third quadrant. So here they must be negative. And again, you can go ahead and try to test. Here, assuming you have cos 360 degrees. Here it is subtraction, and maybe we say 40 degrees. This is equivalent, according to what we picked here, cos of that same angle theta. Now that angle corresponds to 40 degrees. Now when you reduce this down, you have cos of, when you subtract 40 away from 360, we get 320 degrees. If you punch this into a calculator, then the result would be exactly the same. Since we have picked cos, then our results we get will be positive results. And it will be exactly the same. Now, these are the three reduction identities in the fourth quadrant plus the three reduction identities also in the third quadrant, making 6. And we move on here to the second quadrant. We have 5. In the first quadrant, we have 5. So 5 plus 5 is 10 plus the 6 there, we have 16 in total identities that we might use, and this is grade 11 lesson. And that is exactly how we will be able to memorize these identities. That in our next video, we're going to have some example, and I'm going to give you a lot of those examples that requires reduction formulae or identities. So if you have not subscribed, do well to subscribe in order for you to get that notification when the video comes on board. Thank you for watching, and see you in the next one. Peace out.